Okay, gentlemen, let's program this 3D test part in Fusion 360. So, I've already given you the body, which is the stock. Okay, so let's highlight that. Let's make sure we're in our manufacturing forum, which we are. Let's create a new setup. So the stock is from a solid, and our work coordinate system model orientation is going to be z-axis, plane, and x-axis. So for the z-axis, you can see we're highlighted on that. We're going to choose this top of the stock, and for our x-axis, we're going to choose that back x-axis edge. Now we need to flip the x-axis around by clicking on it. You can see we can click on it here to flip it around. Now let's put it in the back left-hand corner, the hard jaw of our vise. So we're going to select selected point, and we're going to simply click that point right there. Now let's define our model. Our model is going to be the 3D test part itself. So simply click OK. So guys, first things first, let's go ahead and face it off. We're going to go as a facing operation, face. And let's call our facing tool, this is all stuff previous. Let me get rid of it. How are we going to do this here? Delete tool, yes. Delete tools, yes. Okay guys, we're starting all over again. We don't need to use what I used to program this thing previously. So we're going to use a facing operation. We're going to select a facing tool. Let's call the facing tool tool number 1 this time. It's a face or a facing end mill, a face mill. Its diameter is 2.5 because that's what we have at the school. Its feeds and speeds 6,000 RPM. Max it out, and let's go 60 inches a minute. Okay. So, from the model top, let's just make that a selection. Climb cut, always climb cut with the CNC, and hit extend before retract. Go ahead and hit OK. And there you have it. Now, let's rough out this part. How we're going to do that is a 3D adaptive clearing, model aware, adaptive clearing in the 3D workspace. Let's use our 1/2 inch end mill. We're going to call that tool number 3. Tool number 3. It's a flat end mill. Its diameter is 1/2 inch, 0.5. Flute length, 1 1/4. And for our spindle speed, let's max it out at 6,000 RPM and call it 75 inches a minute. Our ramping and our plunge feed can also be 75 inches a minute. Make sure we're on tool number 3. Hit OK. OK. So because it's model aware, we don't have to select anything. The stock contours is what it's going to use, the stock that was already defined, that one. Let's not select anything here. However, let's select the bottom point right here and go negative 40 thousandths of an inch. far as our optimum load goes, that 150. And our maximum roughing step down, let's make that 3/4 of an inch. Now this makes our fine step down 75 thousandths of an inch. You guys haven't really taken use of the fine step down yet, but we're going to do it right now. So let's hit OK and see how it generates. Okay, so do you guys see what's happening here? It's roughing this out because it is model aware along this 3D path. So that's simply all we have to do. We'll go over and do the simulation after it's all done. Okay, so now we want to make a contouring pass along this surface up to that point, and I'll tell you why that point is important in just a second. So let's go back and choose our contour in our 2D toolpath. Tool number 3, we can use all of the same parameters. We do need to choose our contours this time, so let's choose that one. Okay, what's different here? It's defining this one. Okay, so go ahead and click on that blue spot and click the open contour. Now we can go ahead and click just the contours we want, and it won't try and close the contour on us. I'm only going to go to that point, and I'm going to hit accept current contour. Okay, now let's go ahead and select the bottom of the part, minus 20 thousandths of an inch. Okay, and then, oops, we forgot to do something. Or I forgot to do something. This little magic key that says tangential extension distance. Let's make that 0.1. Okay, because we want it to start outside the part and we want it to continue beyond that radius right there. Now, why didn't we just go all the way around the part? Very good question. I didn't want that end mill to cut on that face right there. So what I'm going to do is I'm going to make another 2D contouring path to cut along this edge to here. So let's go ahead and do that. Tool number 3, everything's the same in our tool. Our contour, let's go ahead and select that, except that's going to give us this chain. We don't want a chain here. Let's make an open contour and select the lines that we want. Okay, now hit accept the contour, and let's extend a tangential extension of a 100 thousandths of an inch. Okay, and then let's just go a little tiny bit below that surface there. Actually, that surface is fine. I'm okay with using that surface as our bottom edge. So we can just leave that on selected contours and hit OK. Okay, so the reason we did this one and this one separately is I didn't want to touch this surface from this side because I want to get this surface all from the same side when we flip it over for op2. But I do need the entire perimeter cut so that we have something to hold on to when we go to op2 and put it in some soft jaws. Alright, So now we're going to make a three-dimensional toolpath to go ahead and finish this surface right there. So I'm going to do a 3D, I'm going to do a parallel surface, or a toolpath. We're going to do this with a ball mill. So we need to select the ball mill. Let's use tool number two, a ball mill, 1/4 inch in diameter. Feeds and speeds, we can max it out again. 6,000 RPM. And we're not taking a whole lot. Let's try 100 inches a minute. Post processor is on tool number 2. Select OK. Alright, the machining boundary. All I want to take is that surface right there. So we can do this a couple of different ways, but the easy way to do it is to hit this avoid touch surfaces and turn on touch surfaces. And I'm going to simply select the surfaces that I want it to touch. Okay, and let's select all of these radiuses as well so that we can go ahead and deburr the part within the same operation. Okay. We've got those selected. What I'd like to do is leave a stock to leave and a fairly aggressive step over of, say, 60 thousandths of an inch. So I'm leaving 4 thousandths of an inch radially and axially. And let's see what happens when I generate the toolpath. Okay. What we have is some type of a slight problem. I'd like to get all the way around that. Tool on center of boundary. We don't want to be on the center of boundary. That was limiting the boundary to the center point of the tool right here. So let's go on the outside of the boundary and hit OK again. Okay, so if I show you this in a simulation, what you'll find is the tool is moving up and down that line. Okay, so let's see, try and figure out why that thing is red. I don't see it. Huh. Is it a flute length issue? It shouldn't be, but it might be. Let's go ahead and change that flute length and see what we get. Might be that the flute length, it's thinking it's going down farther than the flutes, even though that material is already gone. So let's edit the tool. Let's make our flute length 1 inch, 1.25, our body length 2, and our overall length 2.5. Well, and let's see what we get if we do it now. Not sure why that was a collision, but I'm not going to worry about it right now because I can see that we don't really have a problem. So one of the keys to nice 3D work is a roughing pass, which is our adaptive path, and a semi-finishing path, which, remember, I left that thing 4th thou proud all the way around, and now a finishing pass. That's the way to get a really nice, pretty 3D work. So, here's what the easy way to do this is. Go ahead and click on it, and just hit duplicate. So now, it's the same path here and here. We need to do a couple little modifications. I'm going to make a 20th thou step over to make it really nice and pretty. And this stock to leave. I'm going to take this stock to leave and make it 0. However, I am going to still leave a 2 thou stock to leave in my heights. The reason I'm doing that is I don't want to show any toolpath up here. So I'm leaving it purposely 2/1000ths of an inch higher. Okay? So we're just about done here, but we see that we have not a chamfer here, but a fillet. There's a couple ways we could create that fillet. We could use a round over tool, which we don't have, and every engineer has a different idea of what's an acceptable fillet. So unless you're making lots of parts, the easy way to do that is with a flow toolpath. We're going to use our same 1/4 inch ball mill. We're going to simply select the edges that we'd like to round over, except make sure that the arrow is facing the way that you would like it to go. If it's not, like that case, go ahead and just click on the arrow and it will move the way you want it to go. Again, I'm using that same tool number 2, the 1/4 inch ball mill. Okay, I don't need to go down here because I've already rounded that over with the parallel tool path. I can leave my heights tabs alone, I think. Let's find out. And number of step overs. Let's make it, say, 5 step overs. Direction both ways is fine. Let's see what we get. Okay, you see what we did here? We're rounding this edge over. Let's take a look here. We're rounding over that edge. With our ball mill using 5 different tool paths so it gets a nice consistent fillet. Okay, so now we've got to drill this hole. What size is the hole? I don't know. I'm not a genius. Let's use our inspect option and click on the hole, and it's a 204. So we're going to drill. We need a new tool. We'll call it tool number 4. It is a drill. Diameter is 0.204. Feeds and speeds. We can drill at 5,000 RPM. And call it a 20 thou plunge rate. So 4,000ths per revolution is fairly conservative. We can deal with that. Okay, so let's go ahead and select one of our faces and select same diameter. Okay, but you can see that the drill tip is not going all the way through. So we're going to go over here to drill tip through the bottom. And then let's give it a clearance number of, say, 50 thou. Okay, that's not a deep hole. We don't need to peck. We can simply come down and wrap it out. So we can leave our cycle alone of just drilling with a wrap it out. Okay? Now simply we need to deburr those holes. Go to our chamfer. Our chamfer mill will be tool number 5. Tool number 5. Our cutter. It's a chamfer mill. Its diameter is 3/8 of an inch, and its tip diameter is 0. Feeds and speeds, we can max this guy out at 6,000 RPM. And let's go 75 inches a minute of a feed rate. Go ahead and hit OK. Now we need to make our selections. Make sure that our arrow is on the correct side. We don't need to change anything in our heights tab. Let's give it a 10 thou chamfer. We're not trying to really make a big chamfer, we're just trying to break the edge. And 60 thou down, and our chamfer clearance can be 5 thou. Okay, so we've got operation number 1 programmed on our 3D test part. Let's go ahead and simulate the whole thing. This is a part we're actually going to make when we get back there, so take your time, make sure your tools are properly numbered. And let's go ahead and cut it. I'm going to turn off the toolpath so it doesn't get confusing. Okay, what you see right here is it roughing it out with that 3D adaptive toolpath. Model aware again. And this leftover stock down here is what we're holding on to in the vise. So there's our finish pass, and then our finish pass around the rest. Here comes our ball mill, our 3D, and we're going to come back and finish it nice and fine. Now this is our flow. We're deburring that edge, we're rounding over that edge with 5 passes of the ball mill. Here's our drill, and there's our chamfer. Thanks for following along, guys. If you have any questions programming this part, hit me up on Slack or text me, and I'll try and make a specific video or walk you through it in general. Thank you very much.